Theorem 8.8 tells us that if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. This proof will actually look somewhat similar in its basic setup, and that here we're told A is congruent to C and B is congruent to D. And that's a given. We could draw in another line. Or actually, I'm going to go about this a little bit of a different way. We know that the sum of, so the sum of our angles, so we know that measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D equals 360 degrees. And we know this because this is the sum, let's get a little bit more space, of the interior angles of a polygon theorem. We know all quadrilaterals are 360 degrees. If that's the case, we can substitute and realize that measure of angle A plus the measure of angle B plus the measure of angle A plus the measure of angle B. So we took out C and D and plugged in A and B equals 360. That's by substitution. We then can combine our like angles. We see that 2 times the measure of angle A plus 2 times the measure of angle B equals 360. And that's by simplifying. If we divide both sides through by 2, we get the measure of angle A plus the measure of angle B equals 180. That's division. Which means that angle A and angle B are supplementary. That's the definition of supplementary angles. If that's the case, if A and B are supplementary, then we know from previous theorems that that means that AD is parallel to BC. If we have consecutive interior angles for two lines cut by a transversal, and those consecutive interior angles are supplementary, then the lines must be parallel. Thus, BC is parallel to AD. And that is the converse to the consecutive interior angle theorem. Or you could just write if two lines cut by a transversal and consecutive interior angles are supplementary, then the lines are parallel. Proving that AB is parallel to CD is a very similar process, and you could probably work that out for yourself. Just a quick note, I am showing you these proofs. It's a good thing to know, but what I'm really concerned about is that you just understand what the theorems are saying. Alright, let's look at Theorem 8.9.